So, hi everyone, how you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this particular channel of Unacademy, every concept of physics, chemistry, and maths are being taught to you completely in English, so that no student is feeling left behind due to the extensive usage of Hindi in most of the content available on YouTube. Now, this is a quiz that I'm hosting as a special session today because some of you had requested that you wanted a mega quiz on modern physics. So in our regular discussions in of class 12 topics, we haven't yet reached the topic of modern physics, but still some of you wanted some revision of modern physics. So here we will do that revision today through this quiz. Okay. Now, before I get started with today's lecture, let me introduce myself for those of you who might not know me yet. So my name is Rohit Dixit and I study mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching physics for the IIT JEE Mains and Advanced examinations. So for 7 years, I have taught at offline institutes, which you guys would, which have been some of the most reputed institutes that you know of. And as a student, I myself was All India Rank 447 and All India Rank 192, the two stages of the IIT JEE exams that I took. Now, I also qualified the NTSC Stage 2 examination, and I was in the top 1% in the NACP exam as well. Now, so far, I've coached many students to top ranks in the IIT JEE examinations, both mains and advanced, in my offline setups, and now I hope to continue doing that here online with you guys. So, any student who is looking to, go ahead with their education uninterrupted, even in this era, has a wonderful opportunity now. They can get themselves for themselves the Unacademy subscription. This subscription will bring you benefits like live classes where you now get to interact with your educators on a regular basis. These classrooms also have live polls and leaderboards, and then you have test series and analysis sessions, which are very important for a competitive exam like JEE. And of course, you have live doubt clearing sessions, so where you can take care of all your doubts, be it about theory, be it about your concepts, be it about problem solving, and every one session is entirely dedicated to your doubts. Okay, after every 3 teaching sessions. So these sessions happen on a regular basis, which ensure that you do not pile up with your doubts. So hello Raj, how are you? Hello Mahi, hi Amod, how are you guys doing? All right. Apart from all these benefits, you are also getting the opportunity to get from to study from the topmost educators from all across the country, from the comfort and safety of your home. Now, so I think that's a huge opportunity, and every student must use to look to capitalize on that opportunity. Now, how do you avail all these benefits, and how do you make sure that your studies are going completely uninterrupted? The first step involves you to install the Unacademy app. The moment you do that, you will unlock for yourself free features like free courses. So there are free courses on the Unacademy app, which anybody who has just installed the app can enroll in. Then, of course, you have something called special classes. So this also is completely free. Anybody with the Unacademy app installed can be a part of all these special classes. And then, of course, you have quizzes like the one we are having right now. So to take part in this quiz, all you need to do is just install the Unacademy app and unlock all these free features using the code RDLive. Okay, that is all you need to do. No subscription is needed. You don't need to buy any subscription to start availing these free benefits. Now, once you start availing these benefits and once you find it worth and you want to take your preparation to the next level, then you can decide to get yourself the plus subscription. And for that, these are the steps that you need to follow. You can go to the plus segment of your app, select your goal as IIT JEE, and click on that get subscription button. Now, the moment you do that, you will be redirected to the payment page where you will find a box which will say, do you have a code? So that is where you can enter this code RDLive. This code will give you a 10% off on all your subscription fees, be it for plus subscription or be it for your iconic subscriptions. Now, these fees of various subscriptions are as mentioned here. You'll also realize that when you click on proceed to pay, you get to select for yourself a lot of no-cost EMI options which help you lessen the burden of these payments also. Now, students who don't know what the iconic subscription is, let me tell you quickly a bit about the iconic subscription. So this is something that will take your IIT JEE preparation to the next level. And how does that happen? So from our team of experts, you will be allotted personal coaches. So these personal coaches will closely monitor your performance and mentor you throughout your IIT JEE journey. And along with all the plus benefits, you also get to attend extra IIT JEE workshops, receive expert guidelines from time to time, get a study planner, and get regular test and analysis sessions. So with all these extra features and your personal coaches, your preparation definitely will go to the next level. Now, all the students who have just entered class 11th and are worried about how to go about their preparations for the next 2 years, now Unacademy offers you combo subscriptions. So these combo subscriptions will take care of all your study needs, be it your class 11 CBSE studies, be it your class 12 CBSE studies, and hence your board preparation, be it your IIT JEE Mains preparation, or be it your IIT JEE Advanced preparation. So there are 4 combo subscriptions that you can choose from. The first combo subscription offers you the iconic subscription for IIT JEE and the plus subscription for class 11 and 12. The subscription starts at around 4,600 a month. The second option that you can choose from is the iconic subscription for all 3, and this combo subscription starts at around 5,500 a month. Then you have a combo which offers you the plus subscription for all 3, and this combo starts at around 3,000 a month. And finally, you have a combo which offers you the plus subscription for IIT JEE and iconic for 11th and 12th, and this combo starts at roughly 3,900 a month. So again, you can choose a combo that suits your needs, and definitely go ahead with your preparation of JEE. Next, students following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link. Okay, so that will make sure that you are not missing out on any of the lectures or sessions or quizzes happening on this channel. This will make sure that you're receiving all timely notifications, and everything is definitely made available to you. Now, so finally, let's get started with the mega quiz on modern physics today. Okay, so this is how you can join the quiz. All you need to do is first go to your Unacademy app, then go to the plus section, click on tests, and click on join quiz. So this is what it will look like. So when you log into your app, all you need to do is go and click here. Then you will see the plus option. Click on that. Then you are redirected to this page where you will see a test tab down at the bottom. Okay. So let's see if I can make it visible. So here at the bottom, click on this test. The moment you do that, you will find this option, okay, which will say join quiz. Okay, so now you click on join quiz here. And once you click on join quiz, you will be asked a quiz code. So this is the quiz code for today's quiz. Let me just write it down in the chat as well. And let's have people joining this. The quiz code for today's quiz is 124765. So hurry up and join the quiz using this quiz code. Okay, and as soon as more people have joined, we'll get started with the quiz. Let's see how many of you have joined. Okay, so 4 people have already joined. Great. So well done, people. So today people are joining fast. All right. So let's wait for another couple of minutes, and as soon as we'll wait for 2 more minutes, and then we'll get started with today's quiz. Okay. All right. So let's just give 2 more minutes for people to join. Okay. So anybody who wants to join can use the quiz code 124765 to join this quiz. Okay, and let's have some more people. Let's wait for 1 more minute now, and then we will start with today's quiz. Okay. All right. So here is your quiz code. All you need to do is go to the Unacademy app. Okay. Click on the plus. Click on tests. Click on join quiz and enter the quiz code 124765. That is the code that you need to enter, 124765. So I'm waiting for 1 more minute, and then we will get started with the quiz. Okay, we already have 4 people, 4 learners who have joined us for this quiz. So let's wait if more people join in the next 1 minute. Okay. So again, just waiting for 1 more minute. So hurry up, people, hurry up. Those of you who wanted this quiz on modern physics, so here you have it. Hurry up and join using the quiz code 124765. All right. I think we have waited enough. So should we get started with the quiz then? Are you guys ready? All right. So anybody who wants to join quickly can join the quiz code using the quiz code 124765. Okay. So I will start the quiz within 1 minute now. Okay, last 1 minute for anybody who wants to register for this quiz. Okay. This is a mega quiz, so this has 30 questions. So even if you are a little late in joining the quiz, you can. Okay, don't worry about it. You will get ample opportunity to make it to the top of the leaderboard. Okay, so let's get started then. So good luck to all the participants. Here we go. Starting with the quiz. Okay, so here is your first question. Okay. Question says that a pulse of light of a duration 100 nanoseconds is absorbed completely by a small object initially at rest. The power of the pulse is 30 milliwatt, and the speed of light is 3 into 10 to the power 8. Okay. So you have to find the final momentum. Okay, find the final momentum of the object. Okay. What do you think will be the final momentum of the object? So will it be A, 0.3 into 10 to the power minus 17 kg per meter second? Will it be B, 1 into 10 to the power minus 17 kg meter per second? Will it be C, 3 into 10 to the power minus 17 kg per meter second? Or will it be D, 9 into 10 to the power minus 17 kg meter per second? Okay, so hurry up. Let's see how many of you can figure this out. So you've been told the power of the pulse, you've been told the duration for which it is absorbed, and now you are asked the momentum. Okay, so if you remember your momentum of EM waves, I think this comes from the discussion that we have already had. So you should be able to answer this. Let's see. Okay, so yes, people who are following my lectures would have done this. Yes. So we have already talked about this in EM waves. Okay, the momentum of any light wave is E by C. So P into T would have given you E, and E by C would have given you the momentum. Okay, so well done, people. Next, let's move on to the next question. It says if the binding energy per nucleon of lithium and helium nuclei are of 5.6 and 7.06 electron volt respectively, then in the nuclear reaction, proton plus lithium giving you 2 helium, the energy of the proton must be. So what must be the energy of the proton? So that is what you have to find. So is it going to be 28.24 million electron volt? Is it going to be 17.28 million electron volts? Is it going to be 1.46 million electron volts, or is it going to be 39.2 million electron volts? Okay, let's see. Okay, so the correct answer was A. Okay, none of you got this right. Okay. Let's move on to the third question then. So in a gamma ray emission from a nucleus, only proton number changes, both neutron number and proton number changes. There is no change in the proton number and the neutron number, or is it only neutron number changes? So what happens in a gamma ray emission? Okay, so this should be easy. This is an easy one. So anybody who has read a little bit of their modern and remembers it even slightly should be able to answer this. So why does the gamma ray emission happen? If you remember that, this should be easy to answer. Okay. So there are 3 kinds of emissions, right? That's all right, Abhishek. We have just started with the quiz and there are 30 questions, so you can still join. Join with the quiz code of 124765. So this is only the third question. You still have 27 more questions to go. So join fast. Join fast. You still have a lot of questions, a lot of time. Don't worry. So join कर लो quiz उधर दिखेगा अच्छे से। हाँ, इस पे थोड़ा-सा छोटा आता है, तो ये प्रॉब्लम है। फुल स्क्रीन करना पड़ेगा देखने के लिए। Hmm. All right, let's see. Let's see. Okay, so 75% of you got this right and 25% of you got this wrong. कैसे join करूं? Go to the Unacademy app, go to the click on plus, click on tests, click on join quiz, फिर उसमें quiz code पूछेगा. There enter the quiz code 124765. Okay. All right, let's move on to the fourth question then. The figure represents in a simplified form the sum of the energy levels of hydrogen. The energy axis has a linear scale, and if the transition of an electron from E1 to E2, let's say, were associated with emission of blue light, which transition would be associated with the absorption of red light? Okay, so where will you see absorption of red light? Okay, will it be from E4 to E1? Will it be from E3 to E2? Will it be from E2 to E3, or will it be E1 to E4? Okay, so which of these transitions would involve absorption of red light? Okay. If the transition from, let's say, it should be E3 to E4 to E2. E4 to E2 would were to associated with emission of blue light. Then which of the following transitions would give you absorption of red light? So 100% correct answers. Very good. Well done, people. Very nice. Okay. So Ankit Pandey, as usual, is in the lead, followed by S. Pandey and Raj. All right. Now, moving on to the next question then. The figure indicates the energy level diagram of an atom and the origin of 6 spectral emissions. Example, line of 5 arises from a transition from level B to X. Okay. Now, which of the following spectral lines will not occur in the absorption spectrum? In the absorption spectrum, which one of the following will you not have? Okay, so this is the emission spectrum. Okay. So in the absorption spectrum, which one of the following will you not have? Is it A, 4, 5, and 6? Is it B, 1, 2, 3, 4, 5, and 6? Is it C, 1, 4, and 6? Or is it D, 1, 2, and 3? Okay, so again, remember this. This is easy. This is easy. So for absorption spectrum, what do you want? You want absorption happening and jumping up. Okay, so that's your hint. 15 seconds left. Hurry up with your answers. So here are your options again. Be very careful. Let's see how many of you can figure this one out. Okay. Very well done. So 100% correct answers. Very nice. You guys are actually on a roll. All right. Very nicely done, people. Okay, A was the correct answer. All right. Amazing, amazing. Good going, guys. Let's move on. De-Broglie wave present in the fifth Bohr orbit is. Which one of the following represents the De-Broglie wave present in the fifth Bohr orbit? Okay. Okay, this should be easy. This should be easy. So if you remember your Bohr's model, you should be able to figure out which of the following electron wave would be present in the fifth Bohr orbit. Okay. Hint: wave A is not even possible. Wave A is not even possible. Okay, so this is very easy. If you remember how Bohr explained the electron not radiating any energy with the help of De-Broglie wavelengths, so this should be super easy. Okay, time almost getting up. Again, very simple question. Most of you, I hope, will get this right. All right, so time up. Let's see how you guys did. Okay, strange. 50% of you got this wrong. 50% of you got this right. Okay. So with that question, S. Pandey has taken the lead. All right. Okay, okay, strange. This is an easy one, guys. Let's move on to the next one then. An electron is confined to a tube of length, okay, L, let's say. The electron's potential energy is one half of the tube is zero, okay. Electron's potential energy in one half of the tube is zero, while the potential energy in the other half is 10 electron volt. If the electron has a total energy of 15 electrovolts, then the ratio of the de-Broglie wavelength of the electron in the 10 electron volt region to the tube in to that of the other half is okay, okay, okay. All right. So you are given the potential energy, you are given the total energies. So you should know the ratio of the energies then. Okay. Okay. Let's see. Let's see. This should be easy. Once you relate the energies, you can relate the momentums. Okay. And that would give you an answer. So last few seconds left. Again, a relatively easy question only. Your potential energies have been given, total energy has been given. You can find the kinetic energy. Kinetic energy can be related to, okay. So B was the correct answer, and all you guys gave A. So you got confused. Okay, no worries, no worries. Happens, happens. Never mind. Let's move on to the next one then. So if the thermal energy of a monatomic gas or molecules of mass m at temperature T is of the order of F by 2 kT, then the de Broglie wavelength of matter waves is of the order of, okay. So this should be interesting. You have been told about the energy. It is of the order of F by 2 kT. So what would be the order of de Broglie wavelength? It should be simple. If you know the relation between energy and momentum and de Broglie wavelength, this should be easy. Okay. Again, most of your modern physics questions would be pretty easy. There are only very few basics that you need to know. If you remember your basics well, and then modern physics, trust me, is super, super easy. There is nothing very complicated about modern physics. Okay. So you've been told the thermal energy of monatomic gas molecules to the order of F by 2 kT. Then you have to find the order of a de Broglie wavelength. So very well done. This was easy. Yes, 100% of you got this right. Very well done, people. Hi, Thota Andu. Was it you who had asked for a quiz on modern physics? I think somebody did. I don't remember exactly who. So here we have the modern physics quiz. Okay, moving on to the next question. A cesium photocell with a steady potential difference of 60 volt across it is illuminated by a small bright bulb placed 1 meter away. When the same light is placed at 2 meters away, the electron crossing the photocell carry 1/4 of the previous momentum, 1/4 of the previous energy, are 1/4 as numerous, or are a half as numerous. Okay, so again, this should be easy. You should remember the relation between the distance and intensity. That's your hint. Remember the relation between the distance of the light source and intensity, and the effect of intensity on your energy of electrons or the number of electrons. So I think with those hints, this should be easy to answer. So Tota Nandu, if you want to join the quiz, you can also still join the quiz. This is a mega quiz containing 30 questions. We are still only on question number 9. So there are still a lot of questions to be discussed. You can still join the quiz using the quiz code 124765. So anybody who's joining us right now can still join the quiz using the quiz code 124765. All right, so very well done, people. 100% of you gave the correct answer. Nicely done, nicely done. I told you the modern physics questions are usually easy only. Okay, nothing much to worry about this. Hmm. All right, moving ahead. The speed of an electron having a wavelength, a de-Broglie wavelength of 10 to the power minus 10 meter is. Okay, and you have to relate the momentum with the de-Broglie wavelength and then calculate the speed of the electron. Okay, so which one of the following options would be the correct one? So will it be A 7.25 into 10 to the power 6? Will it be B 6.26 into 10 to the power 6 meter per second? Will it be C 5.25 into 10 to the power 6 meter per second? Or will it be D 4.24 into 10 to the power 6 meter per second? Okay, you know the de-Broglie wavelength, you can find out the momentum. If you can find out the momentum, you surely know the speed. Okay, so this should be easy. Just a little bit of calculation though, but with a little bit of calculation, you should be fine with this question. All right, let's see. Let's see how you guys have done then. All right, so the correct answer was A, and most of you answered B. Okay, never mind, never mind. So yeah, this involved a little bit of calculation. So it's fine if you guys made some mistake. Exam name. Okay, so there is no exam name. Just click on join quiz and quiz code will be asked. Quiz code will be asked. Okay. The energy that should be added to an electron to reduce its de-Broglie wavelength from 10 to the power minus 10 to zero point 0.5 to 10 to the power minus 10 is. So if you are reducing the de-Broglie's wavelength by half, what are you doing to the energy? So you are adding 4 times the initial energy, 3 times the initial energy, equal to the initial energy, or twice the initial energy. So Thota Nandu, what you need to do is go to the app, click on plus, click on test, then click on join quiz. When you click on join quiz, they will ask you a quiz code. So that is the quiz code that you need to enter. Okay, you enter the quiz code 124765, and that is how you will be able to join this. Okay. Now this again should be easy. De-Broglie wavelength needs to become half. So what will happen to the energy? How much more energy would be required? Okay, I'm almost getting up. Okay, so remember the relation between momentum and de-Broglie wavelength, and then the relation between momentum and energy. All right, great, great, great. Well done. So 100% correct answers for this one. Very nicely done, people. All right, S. Pandey still in the lead, followed by Ankit Pandey, followed by Raj, and followed by Tanya. Okay, great, great, great. So let's move on to the next one then. So the next question says the de-Broglie wavelength of an electron having 80 electron volts of energy is nearly. Okay, so you've been given the data. You have been asked. You've been asked the de-Broglie wavelength. Okay. So what is the de-Broglie wavelength roughly going to be? So again, a question requiring a little bit of calculation. So try to do this. Again, will it be A 140 angstrom? Will it be B 0.14 angstrom? Will it be C 14 angstrom? Or will it be D 1.4? Okay, so 25% of you got this right. The correct answer was D. All right, so well done to those who have answered this correctly. Okay, well done, well done. Again, this is the kind of question which required a little bit of calculation, so that's fine. Okay, next, let's talk about this question. If we express the energy of a photon in kilo electron volts and the wavelength in angstrom, then the energy of a photon can be calculated from the relation. Okay. Which of the following would tell you about the energy? Is it E equals h nu? Is it E equals 12.4 h nu? Is it E equals 12.4 into h over lambda? Or is it 12.4 over lambda? Again, that's the only thing about modern quiz questions. Modern physics questions, they just require a bit of calculation every now and then. So again, try and work out the calculations. All right, the correct answer was C. Okay, none of you got C. All right, no matter, no matter. All right. Let's move on to the next question then. Okay, here we go. Question number 14 says a point source of light is at a distance of 1 meter from a photocell and cutoff voltage was found to be V. If the same source is placed at a 2 meter distance from the photocell, the cutoff voltage will it be A, V, will it be B, V by 2, will it be C, V by 4, or will it be D, V by root 2? So if you increase the distance of the light source, point light source from the photocell from 1 meter to 2 meter, what will happen to the cutoff voltage? Will it become, will it remain V? Will it become V by 2? Will it become V by 4? Or will it become V by root 2? Okay. Think about this, and try and take your time while getting this. Okay, this is an easy one only. Okay, very easy one. So let's try and read the size of this screen. That makes it more visible. Okay, so time almost getting up. So think about this. This is an easy question. This is one question that doesn't require too much of calculation. This you should be able to do within the stipulated time. Okay, so last 3 seconds. Okay, time up. Let's see how you guys did. So very nicely done. 100% correct answers. Yes, this was a trick question. The cutoff voltage does not depend on the intensity. It depends on the frequency. Very nicely done, people. So S. Pandey is still in lead, followed by Ankit Pandey. All right, moving on to the next question. Question number 15. The De-Broglie wavelength of an electron in the ground state of hydrogen is. You've been told the kinetic energy. You have been told the value of EV. You have been asked the De-Broglie wavelength. Okay, so try and find this value again. A little bit of calculation. Okay, so you just have to check the units. So is it A 33.28 nanometer? Is it a B 3.328 nanometer? Is it C 0.3328 nanometer? Or is it D 0.0332 nanometer? I'm almost getting up. So let's see how you guys did. Okay, so 25% of you got the right answer C, 25% of you thought A, and 50% thought D. Okay. So again, never mind. So yeah, the calculation, there could be calculation mistakes. So be very careful about your calculations in modern physics. That's the only thing. Now, the radioactive elements decays to form a stable nuclei. The rate of decay of reactant is correctly depicted as. So what is the rate of decay of a reactant? Okay, so these are the four graphs. This should be super easy. So is the rate of decay depicted as A? Is it depicted as B? Is it depicted as C? Or is it depicted as the graph D? Take a look at the four graphs. Which one represents the rate of decay of radioactive elements? Is it graph A? Is it graph B? Is it graph C? Or is it graph D? Again, this is a very, very simple question. And is possible only on mobile, not laptop. Yeah. Not on laptop. Only on the app. You have to have that app in your mobile. Okay, or even in your iPads or devices, other devices. Not on laptop. Yes, Chota Nandu. You have to have the app. You are right about that. Okay, time almost getting up. So that doesn't matter. You can keep answering on your own and keep checking how many of these you are getting right. Okay. So very well done. 100% of you got this correct. This is an easy one. This is a standard graph. None of you should have gotten confused about this in any case. So I'm glad to see that all you guys got this correct. Very well done, people. All right, moving on to the next question then. This is question number 16. It says if M, A, Z, where M is some metal having the atomic number and the mass number as M, A, and Z, and MP and Mn denote the masses of nucleus and proton and neutron, okay, respectively, in units of U, which is the AMU, in fact, where 1 U equals 931.5 million eV per c square. The binding energy is represented as, what is the binding energy? Again, this should be easy. How do you represent the binding energy? So very, very easy. All you have to do is relate the mass of the nucleus to the mass of the protons, mass of the neutrons, and the binding energy. Okay. Should be simple, not too difficult. Okay, so none of you got this right. So correct answer was A. Okay. Okay, never mind, people. Let's move on to the next problem then. Next question says a hydrogen atom is in ground state, then to get 6 lines of emission spectrum, the wavelength of the incident radiation should be. Okay, so should it be 800 angstrom, 825 angstrom, 975 angstrom, or 1025 angstrom? Okay, very, very tricky kind of a question. So try and answer this. Again, here you will have to remember data. Okay, so they should have given you some data. Okay, the conversions. Okay, I don't know without that how will you. If you remember the data, then you should be fine. Otherwise, this may be a problem. So you want 6 emission lines. So to get 6 emission lines, yes, ARJ. Now you are the one who had asked for this. So we are still only on question 18. There are 30 questions in total. So 12 more questions left. You can still join the quiz, Arjun. So go to the Unacademy app, go to the plus, go click on test, click on join quiz, and enter the code 124765. You can still join this quiz. All right, great. Very well done. So 100% of you got the correct answer. Very nice, people. Yeah, now I remember it was you who had requested for this quiz. Because of you, I hosted this quiz. Of 30 questions, I hosted mega quiz on modern physics. All right, so here, let's go to the next question. A photon materializes into an electron-positron pair, okay, and the kinetic energy of the electron is found to be 0.19 mega electron volt. What is the energy of the photon? What will be the energy of photon? So think about this. If a photon materializes into electron positron pairs, the kinetic energy of electron is found to be this. What will be the energy of the photon? Okay. So this is about your energy mass conversions. You should remember how do these conversions take place. Photon is to be converted into electron positron pair. Then what are the rules that will be followed? Energy conservation, momentum conservation, and so on. You should know the correct answer. Okay, so very different answers. 60% thought it was A, 20% thought it was B, and 20% thought it was C. Turns out C was the correct answer. So welcome Arjun to this quiz. I think Arjun got this right. Hmm. All right, never mind. So let's move on to the next one then. If which of the following plots in the figure represents the speed Vn of the electron in an hydrogen atom as a function of the principal quantum number? Okay, so this should be easy. With respect to the principal quantum number, how does the speed change? Okay. Okay. So please note that the lines in the graph A, B, C, D are different from the options. Okay, so if you think line A is the answer, then you have to mark option D. If you think line B is the answer, then you have to mark option A. So please be careful about that. No worries, Arjun. It'll still give you practice, right? You still have more than 10 questions left. So it'll still give you some practice. And then you can watch the rest of the quiz also later, okay? So how does the speed of the electron vary with the principal quantum number? So, okay, 25% of you thought it was A, 50% thought it was B, and 25% thought it was D. Yeah, so options can be very confusing. All right, but I think Arjun got this correct also. So not bad, Arjun. All right, let's move on to the next question. The last 10 questions, guys. Pay attention and good luck. A certain radioactive material can undergo three different types of decay, each with a different decay. A lambda effective or with a different decay, decay constant is lambda, 2 lambda, or 3 lambda. What is the effective decay constant? So, a material can undergo three decays with the rates of these. So, what is the effective lambda? That is the question. Okay. So, is it going to be the 1 over lambda effective equals 1 over lambda plus 1 over 2 lambda, 1 over 3 lambda? Is it going to be B, lambda effective equals sum of all the lambdas? Or is it going to be C, average of all the lambdas? Or is it going to be D, the harmonic mean of all the lambdas? So what do you think? Okay, three disintegrations happening, what would be the effective lambda? Again, this should be easy. Should be easy if you do not get confused. Oh, strange. None of you got this right. The correct answer was B. Ah, it was simple. I thought it was simple at least. Never mind, never mind. Let's move on to the next question then. Okay. So here you say when an alpha particle of mass m moving with a velocity v bombards a heavy nucleus, of charge ZE, its distance of closest approach depends on m as So how does the distance of closest approach depend on? How does it depend on m? Does it depend on 1 by m? Does it depend on 1 by root m? Does it depend on 1 by m square, or does it depend on m? Okay, alpha particle has a mass m and a speed v, and it is bombarded to a heavy nucleus of charge ZE. So you know what happens in the closest approach. What happens when at the distance of closest approach? That should give you the hint of how you would have figured this out. Again, this again should be simple. I think most of you should answer this correctly. Last 10 seconds. So if you haven't answered this, hurry up and try to get the right answer. Okay, time almost running out, people. All right, let's see how you did. The correct answer was A. Okay, and okay, we have had a divided. So okay. Again, Arjun has been getting most of them correct. Very good, Arjun. Okay. Okay, so this is a repeat. This is a repeat of the previous question. So this I think you should all get correct now. If you remember the answer from the previous one. So how does the speed depend on the principal quantum number? Okay. So again, be very careful about your options. Okay, because the options are very confusing. Just be careful about your options. Arjun says, sir, what should I do for a mental block? I mean, in the morning, from morning, neither am I able to take any decision nor focus. So stop thinking about things so much here and start doing it. The mental block is because you're thinking too much, no? Stop thinking and start doing. All right, so 50% of you got this correct. So 50% of you remembered it right. It was option A. 50% of you thought it was C. All right. Hey, Baba, exam pass head, you don't have the time to think. Okay, so just remember that. You don't have the time to waste after petty things, okay? So just focus on this. Okay, so the ratio of half-life of two elements of A and B is TA and TB. What is the ratio of their respective decay constants? Okay, so if you remember how half-lives and decay constants are related, this should be super easy. Option A says TB over TA. Option B says TA over TB. Option C says TA plus TB over TA, or option D says TA minus TB over TA. So you've been told the ratio of the half-lives as TA over TB, and you've been asked what will be the respective decay constant, ratio of the decay constants, lambda A over lambda B. This should be super easy. Okay, this I think is a straightforward question. Okay, you should remember how your half-life and lambda are related, right? And if you do that, then you should be fine about it. I am almost getting up. Hurry up if you haven't marked your answers, and then we'll see. We'll see how you guys do. Okay. So time up. So okay, 60% of you got this right. 40% of you got this wrong, which is very, very surprising. And how can you guys get this wrong? This is super simple, right? Oh, I don't know what you guys are doing. Anyhow, let's move on to the next problem. The lambda E of an electron and lambda P of a proton have the same energy, are related as. Okay, so if both the wavelengths of an electron and proton have been told you, and you've been told that both of them have the same energy. If both of them have the same energy, then how are the lambdas related? Okay. Is it going to be A, lambda P directly proportional to lambda E? Is it going to be B, lambda P directly proportional to root of lambda E? Is it going to be C, lambda P directly proportional to 1 over root of lambda E? Or is it D, lambda P is proportional to lambda square E? I think there is some mistake in the DK question because the answer should be TA over TB. अरे नहीं बाबा, क्या बात कर रहे हो? हाफ लाइफ क्या होता है? 0.693 over 0.693 over lambda. इनवर्सली प्रोपोर्शनल टू लैम्डा होता है ना? कैसी बात करती है अर्जुन? Half life is inversely proportional to lambda, the decay constant. The greater the decay constant, smaller would be the half life. ना ज़्यादा decay करेगा तेज. नहीं. So the answer would be TB over K. Okay, the maximum velocity of an electron emitted by a light of wavelength lambda incident on surface of a metal of work function phi is. Okay. So you have been asked the maximum maximum kinetic energy of maximum velocity of an emitted electron in the photoelectric effect. Okay. So you've been told that light has a wavelength of lambda and it is hitting a surface of work function phi. What would be the maximum velocity of the ejected electrons? It should be easy. Okay, last 20 seconds left. Okay, let's see how you guys did. So 80% of you got this correct. Very well done. C is the correct answer. 20% of you got this wrong. So that S. Pandey has taken the lead back from Ankit. Okay. And Arjun is also climbing up the ladder. Not really, but closing the gap definitely. Last 4 questions for an alpha particle which is bombarded. Okay, so this is again very, this is a repeat question. So that happens sometimes. So the questions are randomly picked from a question bank. So all I do is I select a topic and I select the number of questions. So and the questions themselves are randomly picked. So I haven't seen the questions. So yes, that is why some of the questions get repeated. Okay, but that should be a bonus for you. That should be a bonus for you. Okay. The question says when an alpha particle of mass m moving with a velocity v bombards on a heavy nucleus of charge Ze, its distance of closest approach from the nucleus depends on the mass m as A 1 by m, B 1 by m root m, C 1 by m square, or D m itself. Okay. Let's see if you can figure this out or if you remember the answer from the previous time that you saw this question. Let's see if you can do either of those. Okay. All right, time up. So 100% correct. So you did remember the answer from before. Very nicely done. Last 3 questions or 2 questions, I believe. So let's try to do your best. Okay. 3 questions then. De-Broglie wavelength of a neutron in thermal equilibrium at temperature T is. Okay, so this is interesting. De-Broglie wavelength of a neutron in thermal equilibrium at temperature T is. So is it 30.8 and over a root t angstrom? Is it a 3.0208 over a root t angstrom? Is it C 0.038 over a root t angstrom, or is it a D 0.0308 over root t angstrom? So you will need to do a little bit of calculation here. The problem is there are too many things at the same time, practicals and records and pre-boards and Feb mains all together. अब तो ठीक है, compartmentalize your time, no? Make a timetable and do not get confused. Just divide your time for each. Okay, man, not a big deal, yeah. See, every student goes through this. Okay, it is not a unique situation where you are stuck, right? Every student has this situation. We as students had this situation. Okay, so it's all right. It's all right, yeah. Arjun, you have to learn to manage that. Stop worrying about it so much and just learn to manage it. Okay. That's a problem faced by every student. Don't worry about it. Nothing unique. Okay, so the radiation of energy E falls normally on a perfectly reflecting surface. The momentum transferred by the surface is this should be easy. Is it A 2E by C? Is it B 2E by C square? Is it C E by C square, or is it D E by C? Okay. So again, if you remember the energy of a photon with respect to its momentum, then you should be able to get this. Okay. Or even if you remember the intensity and the pressure, radiation pressure equation, be able to do this. Last 30 seconds. This is the second last question. So try and get the last two questions right. Okay. Hold on to those leaderboard positions, and those who are aiming for the leaderboards, this is your chance. Last two questions. So if you want any change in the leaderboard, now is the time. All right, time is almost getting up. Let's see. Soon enough, we will find out how you guys did. Okay. All right, let's see. So congratulations, 100% correct answers. Very well done, people. Impressive. All right, so all you guys got this correct. Very well done. Raj Pandey maintaining the lead. Ankit Pandey very close. Now is your last chance to get to the top of the leaderboard. The half-life of substance X is 15 years and it decomposes into a substance Y. A sample from a meteoroid has been taken which contained 4% of X and 60% of Y, percentage of the total mass of the meteoroid. Okay, if the substance Y is not found on the meteoroid, what is the approximate age of the meteoroid? So let's see. What do you think is the age of the meteoroid? So is it A 270 years? Is it a B 135 years? Is it a C 60 years, or is it a D 45 years? Okay, so the correct answer was C, and all of you guys marked B. All right, never mind. So the leaderboard finally remains unchanged. All right. So that is the end of our quiz. I hope you guys had a good practice, good revision of your theory of modern physics. Let's just go over the solutions and discuss those also quickly. This is the final leaderboard. First of all, so congratulations, S. Pandey, for finishing at the top of the leaderboard, and Ankit Pandey, well done, and Tanya also finished in the third place, in fact. So well done, and followed by Raj and Arjun. Okay, so well done all you guys for participating here. Now let's take a look at the solutions. Okay, strangely enough, the solutions are not visible, so I don't think we will be discussing these solutions today. Right, never mind. So yeah, unfortunately enough, what happens is that I can't go back to the questions, and the only discussion that we can have of the solutions is when I click on solutions, but those are not visible today. So never mind, never mind. So with that, we will come to the end of the quiz, and this is where we wrap up today's session. And before I take your leave for the day, let me remind you that if you guys are planning to get your Unacademy subscriptions and you still haven't gotten them, then this is how you can go about it. You can go to the plus section of the app, select your goal as IIT and click on the get subscription button. Now, when you do that, you are redirected to the payment page where you can enter this code. You will find a box here which will say, do you have a code? Do not forget to enter this code RD Live. This code will give you a 10% off on all your subscription fees. Okay, now you can choose from two kinds of subscriptions where both in both these options you will get this 10% off. Okay, so you can choose the plus subscription or the iconic subscription. Also, when you click on proceed to pay, you can now also choose a lot of no cost EMI options to reduce the burden of the payment. Okay, now those of you who are not aware of what the iconic subscription is, the iconic subscription is something that takes your IIT JEE preparation to the next level with allotting you personal coaches. Okay, so these personal coaches from our team of experts are allotted to you, and they will mentor you closely and personally throughout your IIT journey. And along with other plus benefits, you will also get to attend a lot of IIT workshops, receive expert timely guidelines from time to time, get a study planner, and get regular test analysis sessions. So trust me, with all these extra features, you will power through your IIT preparation. Next, for class 11 students, now you have 4 combo options to choose from, which will take care of all your study needs for your class 11 CBSE, class 12 CBSE, and your IIT preparations. So these combos are: first combos offers you the iconic subscription for IIT and plus for 11-12. This comes at roughly 4,600 a month. Second combo offers you the iconic for all three, comes at around 5,500 a month. The third combo offers you plus for all three. This combo starts at 3,000 a month. And the final combo offers you plus for IIT and iconic for 11th and 12th. And this combo starts at 3,900 a month. Now, okay, so this again, let's change the date. So the next Unacademy Combat event is going to happen on the 31st of Jan live. You can enroll now using code RD Live. Do well and win rewards and prizes in that. Okay. Next, if you liked today's session, again, don't forget to press that like button and share it with as many people as you can. Now, students following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link. All right, and this is finally my code one more time for RD Live. So this code can be used to unlock your free features of the app, unlock free features of the Unacademy app, get a 10% discount on all subscriptions, on plus and iconic subscriptions, and register in events like Unacademy Combat, etc. So one code, multiple users. Okay, so with that, let's wrap up today's session, and that is it for me, from my side for today. Okay, I will see you next tomorrow with our discussion on waves. Okay, till then, you guys keep studying hard and take good care of yourselves. Bye bye.